everyone. My name is Amirul Farhan. So we are from UniKL, Malaysian Spanish Institute, and this is our mini project update video. Our project is titled Sensor Fusion of Gas and Humidity Sensor for Real-Time Indoor Air Quality Monitoring. In this video, we will present our project progress, including the updated block diagram, circuit development, sensor explanation, the benefit of sensor fusion, and how our system works step by step. So let's go.
Okay, hello everyone. So for this part, I'm going to introduce to you our updated block diagram. So first, as you can see, we have power supply. The power supply will provide stable voltage to all components, which is the input, the sensor MQ135 and DHT22, and then the data will be sent to the data acquisition to be processed to the ESP32. And then after the data processed by the ESP32, the data will be displayed at the LCD, and it will show you the value of humidity, gas concentration, and temperature. So the process data also will be sent to the ThinkSpeed for us to collect the data analysis. So that's all, and then let's move on to the next part.
Next, I will talk about a flowchart. First, start. The program will begin the executions, and next, initialize system and sensor, which is ESP32, MQ135, and DHT22. The ESP32 sets up the Wi-Fi connection, sensor pins, libraries, and any variables needed. So the both sensors, which is MQ135 and DHT22, are initialized so they can start reading the data. Next is read sensor data. The ESP32 collects raw measurements from each sensors. From MQ135 is gas concentration, DHT22 temperature and humidity. This step retrieves the latest environmental data. Next is process data with ESP32. The ESP32 processes or refines the raw sensor readings, such as converting analog values to ppm, validating sensor input, filtering noisy signals, and converting to proper units. Essentially, the ESP32 makes the data ready for display and uploading. Next, display, humidity, gas, and temperature. These readings are displayed on a screen or serial monitor. This is useful for local monitoring. Users can immediately see the sensor values without logging into ThinkSpeed. Next is send data to ThinkSpeed. The ESP32 sends the processed data to the ThinkSpeed's IoT platform using API keys. ThinkSpeed stores the data in channels so you can visualize the readings in graph. Next, wait for 50 seconds. There is a delay, usually because ThinkSpeed limits requests to every 50 seconds. This prevents spamming the server and ensures proper data intervals. Next is loop back. After the wait, the flowchart shows a loop going back to read sensor data. This means the system continually reads data, processes it, displays it, and uploads to ThinkSpeed. This loop runs indefinitely until the device is turned off. Lastly, the system is end. Use only if the program is manually stopped. That's all for me.
Hi, my name is Izzat. I will continue the benefit of sensor fusion. Sensor fusion bring many benefits to the system. Relying on a single sensor can produce unreliable reading because environmental factors like temperature and humidity may affect the sensor output. By combining data from the MQ135, gas sensor and the DHT22 temperature humidity sensor, the system can correct such error and produce more consistent, precise and trustworthy result. This allows users to monitor indoor air quality with confidence and take appropriate action if pollution level rise. For instance, they may approve ventilation, reduce source of pollution, or adjust environmental control for better comfort and health. Furthermore, the sensor fusion approach demonstrates how multiple simple sensors can work together to create a smarter and reliable system, which is one of the key advantages of modern IoT solutions.
Okay, Assalamualaikum. My name is Amir Sharifullah, and for our circuit demonstration, here is our current circuit setup. Okay, for our two sensor, which is MQ135 gas sensor and DHT22 sensor, and also our LCD I2C connected to ASP32 microcontroller, as you can see here, using a jumper wire. Okay, the components are assembled on a breadboard, and the circuit operate correctly with stable voltage and connection. This setup form the basic for our sensor fusion system, ensuring accurate reading collection for indoor air quality monitoring. The design is simple, efficient and easy to reproduce. Okay, to summarize how the system work, number one, the power supply provide voltage to all the sensor and the microcontroller. Number two, the MQ135 and DHT22 sensor continuously collect data about gas concentration, temperature and humidity. Number 3, the ESP32 microcontroller receive raw data and apply sensor fusion to correct any error caused by environmental factor. Number 4, the processed data are then prepared for display or recording, giving user clear and accurate information about indoor air quality. This step-by-step process ensure that our system consistently provide reliable environmental reading in a simple and efficient manner. That's all for me.
Hi, my name is Amir Farhan. So today I want to explain about sensor. The MQ135 gas sensor is designed to detect harmful gases such as ammonia, benzene, smoke and carbon dioxide. It works by measuring change in resistance caused by the presence of gases in the air, outputting an analog value proportional to gas concentration. The DHT22 sensor measures both temperature and humidity accurately. Temperature and humidity can significantly influence gas sensor readings, which is why including the DHT22 in the system is essential. By combining readings from both sensors, the reading can correct the MQ135 output to reflect actual air condition, rather than readings distorted by height, humidity and temperature change. This sensor fusion techniques ensure that the indoor air quality data is accurate, stable and reliable, allowing users to understand environmental conditions and take appropriate action to maintain a safe and comfortable indoor environment. So that's all from me. Thank you.
Circuit, power, sensor placement and calibration concept. Let's take a closer look at the technical aspect of our system. First, the power supply. Power supply is essential for stable operation. Both the MQ135 and DHT22 temperature humidity sensor require a constant voltage to function correctly. Any fluctuations in the power source can affect sensor readings, so we make sure the circuit provides steady and reliable power to all components. Next is the circuit design. The MQ135 and DHT22 sensors are carefully connected to the ESP32 microcontroller on a breadboard. Proper wiring and connection ensure that each sensor sends accurate signals without interference. We also pay attention to the placement of input pins to maintain circuit stability. Sensor placement is another important factor. The MQ135 gas sensor should be positioned where air can flow freely, avoiding obstruction that might trap gases. The DHT22 sensor should be placed away from heat sources to measure through ambient temperature and humidity. Correct placement ensure that the sensor capture accurate environmental conditions. Finally, the concept of calibration is important, even without performing real-time calibration. Calibration is the process of adjusting sensor outputs to match known reference values. For example, the MQ135 sensor might slightly overestimate gas concentration if humidity is high. Knowing this, our system conceptually consider this factor to produce more reliable reading when combining sensor data. Together, these technical considerations, stable power supply, careful circuit design, optimal sensor placement, and calibration awareness ensure that the system function as intended and provide accurate indoor air quality measurements. Thank you for watching our mini project update video. For the next video, stay tuned.